Hi guys, I just wanted to point out radar and how it works on a concave Earth. The only way it works. The lower the frequency of the radar allows the greater range, the greater distance. So you see this wave is a lower frequency, okay? And this is a higher frequency. Higher frequency, greater refraction. Lower frequency, less refraction. That is the reason why, as Wild Heretic points out, you can see a greater distance at 2 megahertz as opposed to 8 megahertz. 2 megahertz, you can see 500 nautical miles, or not see, but detect range. And 8 megahertz, only 150 nautical miles. So, if you understand the amount of refraction that is going on, you can see this number here, 1.000268, is lower than this number here, 1.000286. Okay, so this number is for a longer wavelength. Okay, a lower number for a longer wavelength as opposed to this number, which is slightly higher for a shorter wavelength. So this means that this is refracting more. The shorter wavelength is refracting more than the longer wavelength. Okay, going back to my illustration, that is why with radar we can pick up a greater distance with a lower frequency. The higher frequency is going to refract more. It's going to bend up more like that. That is the reason why we are living in a concave Earth. That's one of the reasons why. See, if you had it going the other way, see, this doesn't make sense. This is on a convex ball Earth. Why would the longer wavelength refract more than the shorter wavelength? It doesn't make sense. So that alone rules out convex Earth and flat Earth for that matter, because light is bending like that. So kudos to Wild Heretic for this excellent observation. I'll give you the link to this. And also, I posed a question too. You know how they talk about a convex ball Earth? We'll talk about the top of suspension bridges being slightly longer than the bottoms. Well, if you understand that at the higher elevations, this is where this higher frequency light is going to frolic to, basically. So at these higher elevations of these towers here, I would expect the light to sag more, to bend more. So you would get a slightly greater distance than you would at the bottom, even though the Earth is concave like that. So I'm actually, I posed this question to Conundrum74, and he's going to work it out for me. So we'll see about that. So just want to bring that up. Radar shows the concavity of the Earth. Thanks for watching.